Hello guys, welcome to this session on Python visualization, data visualization using Python. In the continuation of the same data visualization series, we will be looking at distribution plots, or we will be looking at Seaborn as a library. So, like in the previous session, we looked at how Matplotlib works and what are the features and functionalities that are provided by the library Matplotlib. Now, in today's lecture, we'll be looking at the library called Seaborn, and today the topic for today's discussion is distribution plots. So we will be looking at how the data is distributed, or how the data looks like, what is the spread of our data in different plots, like dist plot, joint plot, pair plot, and rug plot. Okay, so we'll start with importing Seaborn library as SNS. This is a very accepted practice. Most of the Python practitioners use this. So SNS is the short form for Seaborn, and we have done Matplotlib inline so that we can see our visualizations, our graphs, our plots in the output cell. Okay, so now the Seaborn library comes with built-in datasets for practicing and learning. So when you import Seaborn, there are some datasets which comes pre-installed with the library. So there is a dataset called tips. So we create a variable and store the dataset by using SNS dot load dataset, and the dataset we can pass the name of the dataset in the argument. Okay, tips. So now let's look at the head of our data, what my data looks like. So this is what our data looks like. It has 6 columns: total bill, tip, sex, smoker, daytime, and size. Okay, so it the data is from a restaurant where the total bill, what was the total bill? So each row signifies a customer or any table booked by a group of customers, right? Like a family or a group, right? So each row indicates a bill. So what was the total bill? What was the tip that was given to the waiter? What was the gender of the, like, the gender of the one who paid the bill, and whether he or she was a smoker or not? What was the day of the week? What was the time, whether they came for breakfast, lunch, snacks, or dinner? And what was the size? So this is, so first row indicates a female paid the bill and they came in a size of 2. So maybe they were two friends, or maybe like mother and their children, mother and the child, like that. Second row, the total bill was $10.34. Yeah, he gave a tip of $1.66. The gender was male, and he was not a smoker. And he also came for Sunday. He came on Sunday for dinner along with 3 people. So the total size was 3. So this is what my data is, right? So now we will look at how can we use Seaborn, which is a very fascinating and very popular data visualization library in Python, which allows you to make colorful and very meaningful graphs and plots with just one line of code. Okay, so let's look at dist plot. So dist plot shows the distribution of a univariate set of observations. So set of observations, like they can be anything, but they has to be univariate. So like you can see the distribution of any one particular column, because it is helpful to see the distribution of univariates or set of observations, right? So what you have to do is, I want to plot distribution plot. So I will do SNS dot displot, and inside the bracket I will pass some arguments. So these arguments are, I want to plot the, from the tips data set, plot the tip column, right? So this gives me the, from the data frame, it gives me this particular column, and the bin size is 10. So bin size means what should be the size of the, what should be the thickness of each of these horizontal bars. So you will get a plot like this. Okay, so this is a plot which shows that all the tips, how are your tips distributed. So as you can see that most of the tips bill are falling between $2 and $4. So like there is a very high so the restaurant received lot more number of tips between $2 and $4 than between $8 and $10, right? So we see a very small or negligible graph over here. And this particular curve that you see is known as KDE, or kernel density estimation estimator curve. So it looks like, so it is like, if you want to fit normal distribution on your data, then it will look like this. So you can kind of ignore it, or you can use it, as it is up to you, right? Next, if you want to remove the KD layer, then and you just want to have the histogram. This thing is called histogram. Vertical, horizontal, vertical bars are called histogram. So we can do that SNS distribution plot tips for total bill. And now I want to plot total bill, and I don't want to see the KDE, that particular curve. I don't want to see, so I will do KDE is equal to false and bin size is same 10. So I can get a graph like this. So this way I can observe, I can understand how my total bill is distributed. Okay, so as it looks like, the highest number, so the most of the bills fall between 10 to $20, right? So like most of the customers, they whatever they eat, they are paying a bill between 10 to $20, most of the customers, right? And very rare of the customers are paying a bill between 40 to $50, right? So this may be because, so this can be a big family which came for a birthday party, or maybe some like a bigger family which came for a lunch. Okay, so there are like 10 to 15 people who are paying this much of big amount, right? Next, we look at joint plot. So joint plot allows you to basically match up two distribution plots for bivariate data with your choice of what kind parameter to compare with. Okay, so basically distribution plots, you can, so this particular dist plot is giving is allowing us to look at only one variable. Okay, so y-axis is nothing. Y-axis is like how many times this particular data occurs. So like total bill, so the height shows, okay, like around 69 or 65, 68 times the bill has been between 10 to 20, right? So y-axis is just frequency of the same variable. So this graph is just showing information about only one variable called total bill, right? But suppose I want to look at how are two variables distributed with respect to each other. So I want to look at two different variables together. Okay, so we will be using a joint plot, so because it allows us to match up two distribution plots for bivariate data. Bivariate means bi means two, variate means kind of variable. Okay, so it allows you to like plot two distribution plots with different kinds, like scatter. You can have a scatter plot, or you can have a regression plot. Like you can look for a straight line distribution, or you can look like, okay, if you want to fit a line through your data, how will it look like? Okay, similarly you will have this residual plot or a KD plot or hex plot. We will try to look at all of them one by one, right? So SNS dot joint plot, so this is the proper structure or the syntax. You will do SNS and dot, like which plot you want to have, joint plot, or you want to have this dist plot. Okay, and then in the arguments you have to pass your different values, right? So it's very simple and very intuitive for you to understand. It is very easy to understand. So SNS dot joint plot, give me a joint plot. X variable should be total bill, y variable should be, y axis should be the tip, and what is my data, like from which data set I want to plot. The name of the data is tips, and the kind I want is scatter. Okay, so I will get a graph like this. Let me just zoom out a bit for you so that we can see the whole graph in just one picture. Yes. Now, so this is the joint plot we have plotted, where I'm plotting total bill on the x-axis. On the y-axis, we are plotting tip, and the data is the tips data set, and the kind is a scatter. So we get a graph like this. Okay, so on the each dot we get, okay, for this particular bill, the tip was this one. For this particular bill, the bill was around 50 and the tip was around $10, right? And on, see, on the side we are getting the same histogram that we saw. So this histogram is for tips, because on the y-axis I have tips, and this histogram is for total bill. So this is the histogram, why how total bill is distributed. So it is giving me a better information or more information, and I can compare, visually compare the two variables. Okay, so like for this data set, for this data point, the bill is more, so the tip is more. For similarly for this also, so as we can see, there is a trend along this particular, as the bill increases, the total tips also increases. So like it is kind of very simple concept to understand. Like if you are eating for around like 1,000 or 1,000 rupees or 1,500 rupees, you will give a tip of around 50 rupees. If you are just having a burger of around like 100 rupees, so maybe you will give a tip of 5 or 10 rupees, right? Now suppose there is one more parameter. So like in this plot we are plotting the same SNS joint plot for like total bill and tip from the tips data set, and this time I want to have a hex. The kind should be hex, so I will get a plot like this. So all the data points are represented by hexagons instead of these circles. right? So it is the plot for the same thing. The darker the color, that means there are more number of data points for that particular value. Okay, so like, so we see very dark values over here, very dark color over here. That means there are more number of data points for this particular region. That means, so most number of bills are between 10 and 20, and most number of tips are between 2 and 4, $2 and $4. So that's why this is more darker, right? As we can see over here also, this particular area is very dense, right? Then we want to, suppose for the same thing I want to have a regression plot, so I will do SNS.join plot, give me total bill with respect to tip, and the data is tips, and the kind is regression, reg for regression. So now this will approximate my data distribution by a straight line, right? So for my all my data scatter points, it is giving me, if you want to fit a line through it, if you want to see how is the trend, so this is the line you will get. So we have already seen this in the machine learning part of the course, which you can look at the channel, or we will be looking at later on. So we will be making videos about linear regression also, right? So it is the same scatter plot with a line which is showing, okay, this is a trend, how your data looks like. And on the, like, this particular side, we have the distribution, the histogram for the tips, and this on this top axis, horizontal axis, we have distribution for the total bill, right? Next kind of plot that we want to look at is called pair plot. So pair plot will plot pairwise relationship across an entire data frame, right, for numerical columns, and support a color hue argument for categorical columns. So basically pair plot, so like here in joint plot, we are plotting two columns, like the tip versus total bill, manually. So if we do a pair plot, so it will plot all the columns with all with each other in just one line, and it will allow us to have a hue argument which will which can give information about categorical columns. So let's look at pair plot. So it is very simple. We will just do sns.pair plot, and I will pass the data set, because here we need not to define x axis or the y axis, because I want to plot all the columns with all the other columns, right? So sns.pair plot, this, if I do tips, I get this particular output. And right, because it is plotting only the numerical columns, okay. So it is not plotting the categorical columns, like whether he was a smoker or not, what is the gender of the particular customer, and what time of day they came, right? So it will give me a plot for only the numerical values. So let's zoom out a bit so that we can see it completely. Yeah. So like, see, on the y-axis we have, so like, I'm getting small plots like this. It is like total bill with total bill. That's why it's a histogram, because this is just one variable. If you talk about this particular graph, this graph is about total bill. On the y-axis I have total bill. On the x-axis I have tip, right? And this particular plot is about total bill with respect to the size, right? So you can see it's kind of discrete, because you cannot have a size between 1 and 2, or 2 and 3, right? So whether the people number of people can be 1, 2, 3, or 4, they can never be 3.5, 2.5, or 4.75, because they are number of people, right? So like this we are getting all the distributions. So like we have size, tip, and total bill on the y-axis, and we have total bill, tip, and size. So like it's kind of a matrix which is plotting each every numerical column with every other numerical column. So like with this just one line we can see a trend. So like I can see with tip and total bill, there is a trend, right? And size, I can see that most number of customers came with a size of 2, okay. This graph shows that, right, the size and this, if you look at size, so the most common size is 2. So like if you go at any time, you will find more number of customers who came in a pair. So maybe they are a couple, maybe they are friends, or maybe you can say two friends. So the very common observation will be like every table is occupied with two number of customers at most of the time, right? This can be one observation, and it also like very easy to understand, right? Because if you also go to a restaurant, you will observe that most of the tables are occupied with just two people. So in a very rare case, like if unless there is a party, birthday party going on, or whether there is a group team dinner going on, you will rarely see a group of friends. Of course we can find some of tables occupied with like four or five or maybe three people, but this sighting two people eating together in a restaurant is very common, Right. Now, suppose now there is a hue parameter in the same thing. So I want to plot a pair plot of the tips data set. I want the hue to be sex. So the hue is gender. So now I will have a fourth information, or I can also see how the information about data based on the gender. Right. In the palette that I'm using is magma. So palette stands for which color scheme you want to use. So if you want to look at it, is the same plot, but now my pink color signifies the data point that she is a female, and the blue color means it's a male. Okay, so in the same plot as above, in the same plot, now I don't know which data point is like. So this bill is paid by female or a male. This what is the latest data point, whether it was a male or female. But now by adding this hue parameter, I got an information. Okay, blue ones are the male and the pink ones are the female. So I got an information like this. So as the pink ones are more, so it's so in this particular total bill versus total bill plot, we see that women paid more bill than total bill for women was more than total bill for men. Right, and we see for this particular plot over here, which is tip versus size. So we see like this particular area is overlapped with females, right? So you can see I can see more females in this particular plot. So that means that can also signify women gave more tips than females. Okay, the number of tips paid by women are more females are more than number of tips paid by male, right? But we can see that the highest number of tips is always a blue thing. So like only the male people gave highest number of tips or the paid the highest tip, right? So this way this information we can have just by adding this parameter called hue. Right. Suppose now you want to have a rug plot. Okay. So rug plot is actually a very simple concept. They just draw a dash mark for every point on a univariate distribution. Okay. So it's just like making a dashed line for any univariate data. Right. So if you want to suppose you want to have plot sns.rug plot, this is the syntax, and plot the total bill column. So like for every customer they will draw a dash. So this customer came, he paid a bill of $30. Then next customer came, he paid a bill of $40. So they will make a dash. So it's like a counting scheme. So if you see more number of dashes, that means more number of customers paid that much amount of bill, right? Like this. So it is called a rug plot. Right, so you can have a sns.kd plot total bill, and you can have a rug plot. So like you want to see like this is the kd plot, these small dashes, sorry, the small dashes are the rug plot, and this particular curve shows okay the distribution. If you want to fit a normal distribution throughout to all over your uh, total bill data spread, then this is you can summarize all your total bill with this normal distribution curve. Okay, then if you want to do the same for I want to do a KD plot for tips column, then I want to do a rug plot for tips column. So this is what our data looks like. Okay, so like wherever you get this particular dense or more number of ticks, the peak is higher. Okay, because it is showing more number of people paid this much of money, and when you are having less number of ticks, then you have the curve becomes almost zero. So there are just two ways of looking at the same thing. Okay. So thanks a lot for your time. This was all that I had to discuss in distribution plots. The next topic is going to be categorical plots, and we are discussing about Seaborn. The library's name is Seaborn. Thank you. I'll see you in the next lecture.